The product 8 times 48 times 81 is divisible by 6 to the power of k. The largest possible integer value of k is 8 times 48 times 81 divided by 6 to the power of k. 31104 over 6 to the power of k. So we have to figure out what power of 6 can go into this. Okay, let's experiment. If it's 6 to the power of 5, it's 7776. Okay, well, what is 31104 divided by 7776? It is 4. Okay, that's good. How about 6 to the power of 6? That is 46656. So 31104 divided by 46656. Well, obviously that's not going to be an integer. That's a fraction. So that's no good. So the largest value of k for which this is divisible by 6 to the power of k is this guy right here, 5. Number 8, the answer is C. What is the smallest positive integer p for which the square root of 2 to the power 3 times 5 times p is an integer? Well, in this question, there's a couple of different approaches, right? You can just start plugging in these values and figure out it that way, which one gives you an integer, and that'd probably be pretty quick. But the way I would approach it, a little bit better mathematically, is first write it out, right? And then understand that we have to take the square root, and if we do, it's got to be an integer. Now this is 2 to the power of 2 times 2 times 5 times p. So p, when combined with this and this, must give a perfect square. This is already a perfect square, so if you take the square root of that, it's going to give you an integer. So if p was 2 times 5, that would work because it would make this 2 times 2, that's a perfect square. And then if p was 2 times 5, we'd combine this 5 with that 5, and that's also a perfect square. So that's the way I would do it. It's a little bit better mathematically. So that means that p is equal to 2 times 5, which is 10. And like I said earlier, you can also just do it the long way, which is keep plugging in these values, answer choices, into this equation and see which one gives you an integer. Either way would work. So number 7, the answer is C. 6 balls numbered 2, 3, 4, 5, 6, 7 are placed in a hat. Each ball is equally likely to be chosen. If one ball is chosen, what is the probability that the number on the selected ball is a prime number? All right. As all probability questions, we have to figure out the denominator first, in my humble opinion. It's easier. And that is the total possibilities. Well, we've got 6 balls, so the total is 6. Now, the numerator is what we are interested in, that specific thing. In our case, it's a number that's a prime. Well, these are our numbers. How many of those are prime? 2 is prime, 3 is prime, 5 is prime, and 7 is prime. So we've got 4 prime numbers. And therefore, that's the probability. And if you reduce that to lowest terms, it will be 2 over 3. So number 4, the answer is D. The numbers 3, 4, 5, 6, 7, 8, 9, 10, up to 13 are written on separate cards and placed face down on a table. A card is chosen at random and flipped over. What is the probability that the number on this card is a prime number? So, how many cards are there? First of all, let's see here. There's 11 cards. So the probability is going to be something over 11. And which of these are prime? Let's just circle them. 3 is a prime, 5, 7, 11, and 13. So those 5 numbers are prime. So that is what goes in the numerator. There you go. Probability is 5 over 11. And number 10, the answer is E. Which of the following is a prime number? Prime number is a number that cannot be divided by anything except 1 and itself. 20 is divisible by 2, right? So that's not prime. 21 is divisible by 3. So that's not prime. 23 is divisible by only 23 and 1. So it is a prime. 25 is divisible by 5. And 27 is divisible by 9. So The prime number in here is 23, which is choice C. How many numbers in the list are prime numbers? Well, prime numbers are numbers that are divisible only by 1 and itself. So any even number cannot be a prime unless it's 2. So 12, 14, and 16 are not prime because they're divisible by 2. 15 is divisible by 3, so it is also not a prime. But 11 is a prime, 13 is a prime, and so is 17. So there's 3 of those, and therefore number 3, the answer is D. How many prime numbers are there between 20 and 30? So let's first write out all the numbers, all the integers between 20 and 30, and let's talk about them. And remember, it's between, so we're not including 20 and 30. All right, well, 21 is divisible by 3, so that's not prime. And we can cross out all the even numbers because they are all divisible by 2. A prime number is not divisible by anything except 1 and itself. 23, is 23 a prime number? Yes, it is. So circle that one. 25 is divisible by 5, so that's not prime. 27, is that divisible by anything? And the answer is yes, it's divisible by 3. And 29, that is indeed a prime. So there's only 2 prime numbers between 20 and 30, therefore number 6, the answer is C. Glenda, Helga, Iona, Julia, Carl, and Lou participated in the 2017 Canadian Team Math Contest. On their team uniforms, each had a different number chosen from the list 11 through 16. Helga and Julia's numbers were even, Carl and Lou's number were prime, and Glenda's number was a perfect square. What was Iona's number? Glenda, Helga, Iona, Julia, Carl, and Lou. Okay, Glenda's number is a perfect square. So of these, the only perfect square is 16. So that obviously is Glenda's number. Carl and Lou's numbers were prime. Of that list, the only prime numbers are 11 and 13, so those numbers are assigned to Carl and Lou. And then Helga and Julia's numbers are even. The only even numbers remaining are 12 and 14, so those must be assigned to Helga and Julia. So the only number left is 15, and that must be assigned to Iona. So number 10, the answer is D. Gabby lists the number 3, 4, 5, 6, 7, 8, 9. In her list, the ratio of the number of prime numbers to the number of composite numbers is 3, 4, 5, 6, 7, 8, 9. Well, the primes are 3, 5, and 7. The composite numbers are the other guys, the 4, the 6, the 8, and the 9. So there was 3 prime numbers and 4 composite numbers, so the ratio is 3 to 4. And therefore, number 8, the answer is A. How many integers between 10 and 20 are prime? The integers that are prime, that are between 10 and 20, are 11, 13, 17, and 19. So there's 4 of them. So number 5, the answer is E.